Bismillah Rahman Rahim, dear students. Today we have to start addition of vectors by using vector diagrams. In figure 4.3, it shows the addition of parallel forces. Why parallel forces? Just for the simplification, so that's why you can understand the basic logic simply. These forces may be parallel, may be anti-parallel, it depends upon the situation. If 5 Newton vector is added in 5 Newton, then its addition according to the simple algebra is 10 Newton. And what happens with these arrowheads? Because this is vectorial representation, it is a vector representation, it shows the direction. So if these two vectors are added, it will be the big vector, because the 5 Newton is the biggest magnitude as compared to 10 Newton is the biggest magnitude as compared to 5 Newtons and this 5 Newton. See here, it is 5 Newton and here minus 5 Newton. So 5 minus 5 is 0 Newton. There is no vector. It means that the vector disappeared because these two vectors cancel out each other. 5 Newtons plus 10 Newtons, it's 15. 5 minus 10, it's direction. Always do remember that if the vector, one vector is the biggest vector among the two, then the direction of the resultant vector will be towards that biggest vector. Whether it is positive or negative, it doesn't matter, but the direction is always towards. See here, 5 Newton is directed from left to right and 10 Newton is directed from right to left. So the resultant is from right to left. Why? Because 10 Newton is the biggest magnitude. Here it was shown horizontally and it is shown vertically. You can also add vectors whether they are vertical or horizontal. The logic is same. 10 Newton is in upward direction, 5 Newton is in downward direction. It means that 10 minus 5 is 5. And what will be the direction? The direction of the vector will be upward. Here 10 Newtons minus 8 Newtons, 2 Newtons. See, it's a very small vector. It is also small vector as compared to this one. And this is smallest vector as compared to these two. It means that it fulfills the criteria that the vector addition is not only done by using simple mathematical algebra, but also vectorial form. The most importantly, how we can add the two vectors. Now we are going towards some complex steps. We have to add these two vectors, and for the addition of the two forces, actually I'm using the word vectors, and here in your book they use the word force. It doesn't matter because all the vectors are added by using the same rules and regulations. And if I use the word vector, it's fine. But here, if it is written forces, then you have to consider these two vectors as forces. What is going on actually in these two diagrams? These are two different vectors. One is FA and the other one is FB. FA is making certain angle theta A with the x-axis, and FB is making certain angle theta B with the x-axis also. And here note down the x-axis is positive x-axis. So we are going to use first quadrant, and here we are not going to touch these three quadrants because the first quadrant is very simple. In the first quadrant you have the same value like x and y, both are positive. It means that in the first quadrant you just have to use very easily the concept. If you will learn this, then you can move towards the complex things. Here I am going to use head to tail rule for addition of vectors, and head to tail rule is used for the vectorial addition. It means that this is a separate vector, this is a separate vector. These two vectors or forces are added together by using certain steps. So let let us see.